Hello everyone, welcome back to the top percentile. My name is Arbaz and today we will be solving CAT 2024 Slot 1 DILR section. Okay, so a quick announcement. The enrollments of our CAT to CET courses have started. Our team of mentors and faculties who are alumni of top P schools have worked tirelessly to bring you one of the most comprehensive courses out there with abundance of quality practice materials and mocks and personal mentorship. There won't be any need for you to go anywhere else. We will make your life sorted. If you have any queries, please reach out to us and we will be more than happy to help you. Now let's begin with our session. I would suggest you to solve all the sets along with me and not simply watch the video. So grab your book and let's solve. So let's look at the first set. Six web surfers M, N, O, P, X, and Y each had 30 stars, which they distributed among four bloggers A, B, C, and D. The number of stars received by A and B from the six web surfers is shown in the figure below. We have a figure here. The following additional facts are known regarding the number of stars received by the bloggers from the surfers. Okay, so let's first begin with by making a table. Before moving on to the additional facts, we'll note down the data that's already given to us. So this will be M, N, O, P, X, and Y. These are the web surfers and the bloggers A, B, C, D. Let's also write the sum. Okay, let's quickly make the table. Okay, these are the web surfers and these are the bloggers. So M gives out 10 stars to A here. So we'll note it down 10 here. N gives out 25. Similarly, O gives 0, P gives 5, X gives 0, and Y gives out 5. Okay. So we have got all the stars received by A. Let's move on to B. So B receives 0 from M, from N, from O, from P it receives 25, from X it receives 0 again, and from Y it receives 20. Now remember that the data for B is not missing here, it's actually 0. So if you can see, we do not have any mention of C and D here. So for that we can say that okay, the data is missing, but for A and B the data is complete. It's just that the values are 0. Okay. In the first line it was mentioned that all these six web surfers have received 30 stars each. So their sum will be 30. Okay. Here I can see that we already have 5 plus 25, which is 30. So the stars given out by P to C and D will be 0. Okay. So yeah, now I think we can move on to the additional facts. So the first point is the number of stars received by the bloggers from the surfers were all multiples of 5, including 0. So from the first point, we can say that all the points are in the multiples of 5, including 0. So I can remember that. So first point is taken care of. The second point says the total number of stars received by the bloggers were the same. Okay. So the stars received by A, I can add them up. It will be 25 plus 5, 30, 35 plus 10, 45, and everyone received the same, so everyone will have 45 points. Okay, so this is nice. Second point is taken care of. Each blogger received a different number of stars from M. Okay, so M has already received 10 and 0 stars. I want to get to the sum of 30. So can it be 0 and 20? No, it can't be because I already have 0 here. So the next is 5 and 15. Uh, yeah, it can be 5 and 15. So C can be 5, then D will be 15, and if C is 15, D will be 5. So I have both the cases. So third point is also taken care of. Let's look at the next 2 points. Two surfers gave all their stars to a single blogger. Okay. So let's go to surfer N. Can N give single points to only one blogger? No, it can't. I already have given 25 here, so I need to give out 5 more. So N can't be the surfer. O, yes, O can be. O has not given any points yet, 0, 0. So I can give 30 to one single blogger. So 30 can go here. P, no chance. For X, again, yes, it has not given any, so 30 can go here as well. For Y, it has already given 5 and 20, so it can't give a single blogger all its stars. Okay, so fourth point is also taken care of. I found two surfers. Okay, fifth point is D received more stars than C from Y. Okay, let's take a look at Y. So Y already has 5 and 20, so now I can give out 5 more. So if this is 5, this has to be 0, and if this is 0, this has to be 5. Fifth point says that D has received more stars than C, which means that D will be 5 and C will be 0. Okay, so fifth point is also taken care of. Now, what more can we uh, add in this table? So one thing, if you can see, 30 can be given out by O. So if 30 gives out, if O gives out 30 stars to C, then it will give out 0 stars to D. Okay. And similarly, if O gives out 30 stars to C, X will give 0 here, because if X also gives 30 stars to C, then 30 plus 30, and also I'll have some value from M, so it exceeds 45, which is my sum, so it won't be possible. So that's why it will be 0. And if X gives 0 here, this has to be 30, because I have to reach to my sum, which is 30. Okay. Similarly, if O gives out 0 to C, it has to give 30 to D, and if it gives 0 to C, this has to be 30, and if this is 30, this has to be 0. Okay, so now I think we'll have to work more on this table. So let's take the first case, that is if C is 15, if M gives out 5 stars to 5 stars to C. Okay, so if I take 5 here, and I need to reach the sum of 45. Okay, so I can take 30, 30 plus 5, it's still 35. Okay, so this also works. And if 30 plus 5, if I get 35, I need 10 more to reach 45. So that means N will have to give out 10 stars. But is this possible? N has already given 25 stars, so I only have 5 more to give so as to reach my sum of 30. So it is not possible. So which means that M will give 15 points to C and not 5. So this will be 15. And if this is 15, D will give 5 points. So this will be 5. Okay. Now let's work out a bit more. Now if C is 15, uh, I have to take 30 from either O or either X. Okay. So 30 plus 15 will give me 45. My sum is already taken care of. So that means N will give 0 stars to C. And if it gives 0 stars to C, all I am left with 5 more stars, which completes my sum of 30. Okay. So now I have 15 and 30 can be either from X and O. If I have 5, 5 and 5, which is 15, again 30 can be from either. So I cannot reduce these cases further. So let's move on to the questions. So question number 1 says, what was the total number of stars received by D? So let's go back to our table. The total number of stars, so this is our D, total number of stars received by D is 45. So I have my first answer here. This will be 45. So the first question is taken care of. Question number 2. What was the number of stars received by D from Y? Okay, so we have our Y here and stars received by D from Y will be 5. So answer will be 5, which is option A. So second question is also taken care of. How many surfers distributed their stars among exactly 2 bloggers? Okay, so M gives out stars to 3 bloggers, so it can't be M. N gives out stars to 2 bloggers, which is 25 and 5, so I have N. M gives out O gives out stars to only 1 blogger. You can see this can, if this is 30, it will be 0. If this is 0, it will be 30. So it won't be O. P gives out to 2 of them. Okay, so we have P as well. X will again give out to only 1. Y gives out to 3. Okay, so I have N and P. So that means there will be 2 surfers who will give out their stars to exactly 2 bloggers. Okay, so question number 3 is also done. Question number 4 says, which of the following can be determined with certainty? Okay, the first point is the number of stars received by C from M. So let's see if I have the value. Stars received by C from M is 15. So I have it with certainty. This will be correct. The number of stars received by D from O. Let's go back to our table. Received by D from O. Okay, so now the value will either be 0 or it will either be 30. So I can't say it with certainty, which means the second point I cannot determine it with certainty, which means my answer will be only one, which is option B. So question number 4 is done as well. So pretty good set. Let's move on to the next one now. Let's look at the second set. The chart below provides complete information about the number of countries visited by Dheeraj, Samantha and Nitesh in Asia, Europe and the rest of the world. Okay, so we have a bar graph here and it shows the number of countries visited. Okay, so the number of countries visited by Dheeraj in Asia is 3, in Europe it's 7, in rest of the world it's 1. Similarly for Samantha, she visits 0 countries from Asia, 9 countries from Europe and 4 countries from rest of the world. For Nitesh, this will be 1, this will be 6 and rest of the world will be 12. Okay. The following additional facts are known by about the countries visited by them. Okay. 32 countries were visited by at least one of them. Okay, we'll come back to this point later. USA, a country from the rest of the world, is the only country that was visited by all three of them. Okay. China, only country that was visited by both Dheeraj and Nitesh, but not by Samantha. Okay. France, country from Europe, is the only country outside Asia which was visited by both Dheeraj and Samantha, but not by Nitesh. Okay. So one thing we can figure out from here is that I'll have to make multiple Venn diagrams here for all three regions. Okay. So let's start with Asia. So in Asia, the number of countries that the people visited is 3 plus 0 plus 1, that is 4. Now let's make Venn diagram for them. This will be Dheeraj, this will be Samantha, and this will be Nitesh. So I have D, Samantha S, and Nitesh N. Okay, so from Asia, Dheeraj visits 3 countries. So this will be 3. Samantha visits 0 countries and Nitesh visits 1 country. Okay, so Asia is done. Let's draw one for Europe now. The number of countries people visit from Europe is 7 plus 9 plus 6. 7 plus 9 is 16 plus 6 is 22. This will be 22, and I'll have a Venn diagram for them. So this is Dheeraj, Samantha, Nitesh. From Europe, Dheeraj visits 7 countries. This will be 7. Samantha visits 9 countries and Nitesh visits 6 countries. Okay. Now we'll see rest of the world. So this will be 1 plus 4 plus 12, that is 17. So I have 17 here. The Venn diagram for this, Dheeraj, Samantha, and Nitesh with DSN. Now, Dheeraj visits 1 country from the rest of the world. Samantha visits 4 and Nitesh visits 12. So it is 1, 4, and 12. So this is 1, this is 4, and this is 12. Okay, so we have 3 Venn diagrams here. Now, let's fill the data. If you can see from Asia, Samantha visits 0 countries. So all these values will be 0. Okay. So yeah, this piece of information we can fill from here. Now let's take data from the points that are given to us. So we have Asia first. So let's take the second point. It mentions Asia. So third point says that China, a country from Asia, is the only country that was visited by both Dheeraj and Nitesh, but not by Samantha. Okay. So visited by both Dheeraj and Nitesh and not Samantha is this one. This country is China. Okay. And this is the only country visited by both of them and not Samantha. So similarly, this will be 0 and this will be 0. Okay. So I'm done with my third point. If you can see here in Asia, Dheeraj visits only 3 countries. I already have one. So this will be 3. And Nitesh also visits only 1 country. So I already have 1 here. So this will be 0. So this Venn diagram pretty much fills itself. Now let's move on to the next point. Let's take Europe point now, so which is my point number 4. France, a country from Europe, is the only country outside Asia which was visited by both Dheeraj and Samantha, but not by Nitesh. Dheeraj and Samantha, but not by Nitesh, is this point, which is nothing but France. Okay, so for the other Venn diagrams, this will be 0 because it's the only one that's visited by them, and this we already have 0. Okay, so I'm done with my fourth point as well. So the second point, okay. So for rest of the world, I have second point. USA, a country from rest of the world, is the only country that was visited by all three of them. So this intersection will be USA visited by all three of them. This is the only country visited by all three of them. So that means this will be 0, and this already we have as 0. Okay, so this is nice. And I'm done with my second point as well. Okay, from rest of the world, you can see that Dheeraj travels to only one country. I have one here, 0, 0, so this will also be 0. Okay, so I have uh, points here to fill. Dheeraj here travels in Europe region. Dheeraj travels to 7 countries in total. I have 1, 0, 0, so this will be 6. So this is also done here, and my first Venn diagram is already complete. Let's move on to the fifth point. Half of the countries visited by both Samantha and Nitesh are in Europe. Okay, so they are telling us that this region traveled by Samantha and Nitesh. So half of the countries they would travel are here, and rest of the half will be here and here, right? So let's look at Asia now. So the number of countries traveled by both Samantha and Nitesh in Asia is nothing but 0. Here we know it half of the countries that travel will be from here, which means that the rest of the half of the countries that they traveled by visited by both. Sorry, this will be here. So half will be here, the rest of the half will be here. Okay. So what I can do now is I can introduce a variable here. Okay. So let me take this as x, and they both will travel to x countries. Half of the countries they both travel to be will be x. So the other half will also be have to x. So if this is 1, this has to be x minus 1. Okay. So now if this is x, uh, I know the sum of this particular set is 9. So I have 1 plus x. Let me do this as 8 minus x. So it will give me 9, right? 8 plus 1 plus x minus x will give me 9. And the sum of this set is 6. So what I'll do here is I'll write this as 6 minus x. So 6 minus x plus x will give me 6. Okay. Let's go to rest of the world. I have 4 here in total. So x minus 1 plus 1 is giving me x. So let me write this as 4 minus x, which will give me 4. And the total here is 12. X minus 1 plus 1 is x. I need 12. So I'll write this as 12 minus x. Okay. So I'm done with my fifth point as well. And I've completed all my Venn diagrams as well. So now we'll go on to our last point. That is the first point. 32 countries were visited by at least one of them. So the first point, it says nothing but that the countries visited by exactly once, exactly twice, and exactly by three of them. Okay, the number of countries visited by each by exactly 1, by exactly 2, and exactly 3, this is 32. Okay. So what we can do is we'll add up them. So countries visited by exactly 1 in Asia is 3 plus 0 plus 0. So this is 3. 0 plus 0 plus 1, it is 1, and we have 0. So the sum will be 4 from Asia. So this will be 4 plus from Europe, the number of countries visited by exactly 1 is 6 plus 8 minus x plus 6 minus x. So this will be 6 plus 6, 12 plus 8 is 20, 20 minus 2x. So this will, okay, so 20 minus 2x, and let's add this as well, exactly 2 and exactly 3. So it will be 20 minus 2x plus 1, 21 minus 2x plus x, 21 minus x. Okay, so I'll have here as 21 minus x. And for rest of the world, exactly 1 is 0 plus 4 minus x plus 12 minus x, which is 16 minus 2x, plus 1, 17 minus 2x, and plus x minus 1 will be 18. uh, I'm sorry, 17 minus 2x plus x minus 1. So I'll get this as 16 minus x. Okay, so this will be 16 minus x. This will be 32. So 21 plus 4 is 25, and plus 16, 25 plus 16 will give me 40. 1 second, exactly 1. Okay, so we have made a mistake here. If you can see that Dheeraj travels to 3 countries in total, I have already written 1 here, so this will be 2. Okay, so 2 plus 1 will be 3, and here this will be 3. The total number of countries they will visit is 2 plus 1 plus everything is 0, so this will be 3. Okay, so what I'll have here is 24 plus 16, this will be 40 minus 2x, this will be 32, this will be 2x equals to 8, and x will be 4. Okay, so now when x is 4, let's complete the Venn diagrams. So when x is 4, 8 minus x will be 4. X, I know it is 4. When x is 4, 6 minus 4 will be 2. Here when x is 4, 4 minus 4 will be 0. 4 minus 1 will be 3. And 12 minus 4 will be 8. Okay. So my Venn diagrams are complete. I can move on to the questions. How many countries in Asia were visited by at least one of Dheeraj, Samantha, and Nitesh? Okay, let's go to Asia. Countries visited by at least one of Dheeraj, Samantha, and Nitesh. Okay, so it will be 2 plus 1. So this has to be 3. So the answer to my first question will be 3. How many countries in Europe were visited only by Nitesh? Okay, let's go out to Europe and Nitesh. Okay, so were visited only by Nitesh is this section. So it is 2. My answer to the question number 2 will be 2. This is done. How many countries in the rest of the world were visited by both Nitesh and Samantha? In rest of the world, countries visited by Nitesh and Samantha. So Nitesh and Samantha, countries visited by both of them will be 3 plus 1, that is 4. So 3 plus 1 is 4. So the answer to my third question is 4. And the last question, how many countries in Europe were visited by exactly one of Dheeraj, Samantha and Nitesh? So in Europe, countries visited by exactly one of Dheeraj, Samantha and Nitesh will be 6 plus 4 plus 2. That will be 12. So the answer to this will be option A. I'm done with my question number 4 as well. Let's look at the third set. The game of quoit is played between two teams. 6 teams numbered 1, 2, 3, 4, 5 and 6 play in a quoit tournament. These teams are divided equally in two groups. In the tournament, each team plays every other team in the same group only once, and each team in the other group exactly twice. Okay, the tournament has several rounds, each of which consists of a few games. Every team plays exactly one game in each round. Okay, so till here what the data tells us is that I have two groups, that is group 1 and group 2, and I have three teams in group 1. I have three teams in group 2. Okay, and these teams play amongst each other in their respective group once, and they play twice with the different group teams. Okay, so for the first group, I have three teams. So the number of matches they'll play will be 3C2. Okay, I have three teams. Each team will play against each other. Two teams will play against each other. So I have 3C2. This will give me three ways. So I'll have three matches in group 1. Similarly, three teams, two will play against each other. This will also give me three ways. So I have three matches that will played amongst each other in group 2, and three matches that will be played amongst teams in group 1. Now, amongst different teams, so I have three teams from group 1, they'll play against three teams from group 2, and it's mentioned that they play twice when the groups are different. So I'll have two matches of them. This will give me 18. So overall matches that will be played will be 3 plus 3 plus 18, which will give me 24. Now, in one round, there can be only three matches played, right? If one plays match with 2, 3 plays with 4, 5 plays with 6, maximum there can only be three matches played in one particular round. So how many rounds will I have? It will be 24 by 3. That means I have 8 rounds. Okay, so let me make a table for 8 rounds here. So I have round 1, round 2, round 3, 4, 5, 6, 7 and 8. I'll have three matches played in each round. Okay, so let me make this more nicely. Okay, now let's go ahead and look at the additional facts that's given. Each team played against a team from the other group in round 8. Okay, so in round 8, group 1 will play matches with the teams from group 2. Okay, in round 4 and round 7, the matchups, that is the pair of teams playing against each other, were identical. Okay, so this is an important point. From round 4, in round 4 and round 7, the pair ups, the matches played against two teams will be completely identical for all the matches. Okay. Similarly, in round 5 and round 8, the matchups were again identical. So in round 5 and round 8 as well, the matchups will be identical. In round 8, I know two different groups play matches against each other. So this will also be replicated in round 5 as well. Okay, so I'm done with point number 2. Let's look at point number 3. Team 4 played team 6 in both round 1 and round 2. Okay, so team 4 plays team 6 in both round 1 and round 2. Now, what additional data can I get from point number 3? If you see in the data that we have already read out, it was mentioned that each team in different groups play exactly twice. Okay, so since 4 and 6 are playing two games, that this means that 4 and 6 will be in two different groups. So 4 will be in this group and 6 can be in this group. Okay, so I have 4 and 6 plotted in groups. Let's move to point number 4. Team 1 played team 5 only once, and that was in round 2. Team 1 will play team 5 only once. Now, what additional data can we infer from point number 4 is that if they play only once, this means that they both will be from same group. So I can write somewhere here that 1 and 5 were from the same group. Okay, so I'm done with point number 4. Point number 5 says team 3 played team 4 in round 3. Team 3 played team 4 in round 3. Team 1 played team 6 in round 6. Team 1 played team 6 in round 6. Point number 5 is done as well. Point number 6 says in round 8, team 3 played team 6 while team 2 played team 5. So 3 6 is done, 2 5 is done. I'm left with 1 4. So I can write that 1 and 4 play third match from round number 8. I know the pair ups are identical in round 5 and round 8. So this will be same here as well, 2 5 and 1 4. Now, if you remember from point number 1, it was mentioned that each team played against a team from the other group in round 8. So, point number 1 said that the matches played in round 8, so both the teams will be from different groups. So, 3 and 6 are from different groups, 2 and 5 are from different groups, and 1 and 4 as well, they are from different groups. So, I have 4 here. I know 1 and 4 are from different groups. So, this means that 1 will be here. Here I have already written that 1 and 5 are from the same group. So this means my third team will be 5. All I am left with team number 2 and team number 3. So I have completed my groups table here. Now let's move ahead. Okay. So what additional thing that we can bring out from here? So let me first pull out, take a table a bit down here so that, okay. Now let's see that what matches can be played amongst each other by the same group and by the different group. Okay, so in the same group, let me bring this as well down so that we don't have to go back up again and again. Okay, so say in the same group, in group 1, so what are the matches that can be played? So one match can be 4-2, other match can be 4-3, and the third match can be 2-3. Okay, in group number 2, what matches can be played? It can be 6-1, it can be 6-5, and it can be 1-5. Okay. Now from different groups, 4 can play against 1, can with 5, and against 6, 1 and 5. Okay. So I'll have 4 against 6, 4 against 1, 4 against 5. Similarly, 2 can play against 6, 2, 1, 2, 5, and I'll also have 3 playing against 6, 3 playing against 1, 3 playing against 5. Okay. So these are the overall number of matches that will be played. If you remember, the number of matches played in the same group amongst each other will be 1, and across group, that is in the different group, the number of matches that will be played will be 2. Okay. So let's just tick off whatever data we have already taken in the table. So I know that 4 and 6 have already played both of their games, so I can tick it off here. 3 and 4 have already played one of their game. Okay, so 3 and 4 goes. 1 and 5 have played their only game. 1 and 5 goes. 3 and 6 have played both of their games. 3 and 6 goes. 2 and 5 have played both of their games. 2, 5 goes. 1 and 4 have played both of their games. 4, 1 goes from here. Okay, this is done. 1 and 6. 1 and 6 have played their one game, so this is also done. So all so the other data points that I have to plot it. Okay. So if you see that, let's go to round 1. In round 1, 4 plays against 6. So I'm left with 1, 2, 3, and 5. Okay. So can 1 play against 5? No, 1 cannot play against 5. We have already used that game. So 1 can play against 2, or 1 can play against 3. Okay. Now I am left with the fifth team. So fifth team can not play against 1. So fifth team can play against 2, or fifth team can play against 3. Okay. So see if these cases are available. Fifth team playing against 2. Team number 5 playing against 2. So this is already done here. I cannot take this. So this means that team number 5 will play its game with team number 3. So this will be 5 playing against 3, which means in the second game of round 1 will be played by team 1 and team 2. Okay. So team 1 and team 2, I had 2 games. I am left with just 1 game. Team 3 and team 5, I had 2 games. Now I am left with 1 game. Okay. Now team 4, team 6 is done. Let's look at round 2. Team 4, team 6 is done. Team 1, team 5 is done. I am left with team 2 and team 3. Okay. So team 2 and team 3 will also be cut off. Now I'll go to round 3. Round 3 and round 6, we have one data given. See, now let's try to find what will be in round 4 and round 7, because we know that they both will be identical. So even if I find one row, I'll be able to find that will be the same data in round 7 as well. Okay. So can 4 to come in round 4? No, it can't, because I want 2 games. One game will be played in round 4, and one game will be played in round 7 by the same pair of teams. So I cannot look at 4-2 for that. I cannot even look at 6-5 for that, because I don't have 2 games for this uh, pair of teams. So the only teams that I can look at will be 4-5, 2-6, and 1-3. I cannot look at 1-2 here because I only have one game left to utilize. I cannot look at 3-5 as well because I only have one game of 3 and 5 to utilize. So that's it. I just have to, I wanted three cases and I have got three left. So the round 4 will have 4, 5, 2, 6 and 3, 1. And the same will be repeated in round 7 as well. This will be 4, 5, 2, 6 and 3, 1. So I'm done with 4, 5, 2, 6, 3, 1. All I'm left with is one game of 2, 1, one game of 3, 5, one game of 4, 2 and one game of 6, 5. So let's go to 3 and 4. So 3 and 4 is utilized. I want games with 1, 2, 5 and 6. Okay. So I cannot take 4, 2. I cannot take 6, 5. Okay, I can take 6, 5. I cannot take 4, 2. I can take 6, 5. I can take 1, 2. I cannot take 3, 5. Okay, so I just have two cases that I can take and I need two cases here. So let's just put this. So this will be 6, 5 and this will be 2, 1. I'm done with this case as well. I'm done with this case as well. I'm only left with 4, 2 and 3, 5 and I'm only left with two idle slots to fill. So this will be 4, 2 and this has to be 3, 5. I'm done with this case as well. I'm done with this case as well. So I'm ready with my table. Now I can go ahead and see what the questions are. Question number 1 says, how many rounds were there in the tournament? We know that there were 8 rounds in the tournament. So we get question number 1. What question number 2 says, what is the number of the team that played team 1 in round 5? In round 5, the team that played team 1 is 4. So the answer to this will be 4. Question number 3 says, which team among the teams numbered 2, 3, 4, 5 was not part of the same group? Okay, so I have 2, 3, 4, 5 is in different group. So answer will be 5, which is option A. Question number 4 says, what is the number of the team that played team 1 in round 7? Let's go to round 7. Team 1 is paired up with team 3. Okay, so this is team 3. Question number 4 is also done. Let's look at the last question. What is the number of the team that played team 6 in round 3? Round 3, team 6 is, so the opponent is team 5. Okay, so this is the answer to my question number 5 and we are done with this set. Let's look at the fourth set. The chart below shows the price data for 7 shares A, B, C, D, E, F and G as a candlestick plot for a particular day. Okay, the vertical axis shows the price of the share in rupees. Okay, so this is price. A share whose closing price, that is the price at the end of the day, is more than its opening price, that is the price at the start of the day, is called a bullish share. Otherwise, it is called a bearish share. Okay. All bullish and bearish shares are shown in green and red color respectively. So they are color coded. Okay. Let me make a table here now. So I'll have day's lowest price, day's highest price. I have opening price, I have closing price, and here I'll have A, B, C, D, E, F, and G. Okay, so Okay. Now, we can see that it's already explained to us here what are the lowest prices and highest prices. And for bearish share, this is the bearish share since it's in red color, and this is the bullish share, so which is in green color. So we know the opening price and closing price for this as well, and here the order for the opening and closing will change. Okay, so let's put this data into the table so that we can read it properly then. So for A, lowest price is 1200, highest price is 2400. Since it is a bearish share, opening price will be 2200 and closing price will be 1800. Similarly for B, lowest will be 1400, highest will be 2000, opening price will be again 2000 and closing price will be 1700. Okay, let's go to C. Now C is in green color, which means it is a bullish share. Okay, so lowest it will be 800, highest it will be 1400. Opening price for C will be 800 and opening closing price for C will be 1200. D again, it is a bullish share, lowest is 300, highest is 1200, opening will be 500 and closing will be 1000. Let's go to E. It is a bearish share, lowest is 1100, highest is 1400, opening will be 1300 and closing will be 1100. Let's go to F. Again, it's a bearish share. Lowest is 1200 and highest is 2000. Opening is 1800 and closing is 1600. Okay, let's go to G. It is a bullish share. Lowest is 1000, highest is 1900. The opening is at 1200 and closing is at 1700. Okay, so now pretty much I have completed the table. Now I don't think we can do anything more. Let's move on to the questions. So question number 1 says daily share price variability SPV is defined as days highest price minus days low price upon average of the opening and closing prices during the day. Which among the shares A, C, D, and F had the highest SPV on that day? Okay, so I need to find SPVs for A, C, D, and F. If I take a glance at question number 2 as well as no, only question number 2, I can see that I have to find out the number of shares for which SPV is greater than 0.5. So what I understand is I have to anyways find out the SPV for all the candlesticks, that is from A to G. So let's just find it for all the values. So let me bring this table down so that we don't have to go up again and again. Okay, so I think this is better. Okay, so I have to find SPV for all these values. So for A, what is SPV? SPV is days highest price minus days lowest price upon average of opening and closing prices. Okay. So days highest minus days lowest will to 2400 minus 1200 upon average of opening and closing. So the average will be 2000, 2200 plus 1800 by 2. So you should be able to do this quickly. So this is 2000. 2400 minus 1200 is 1200. 1200 upon 2000 will give me 12 by 20, which is 6 by 10, which is 3 by 5. So the value for this will be 0.6. Let's go to B. For B, it will be 2000 minus 1400. This will be 600, and average of 2000 and 1700. So this will give me 1850. Okay. So this will give me 60 by 85. Let's divide it by 5. So this will be 12, and 5 3s are 15, 5 7s are 35. So I have 12 by 37. So 12 ones are 12, 3s are 36 point something. So the value for this will be less than, so 1 by 3 is 0.33, so the value for this will be less than 0.33. Okay, so I can write that. Let's move on to C. For C, it is highest minus lowest. It gives me 600 upon 1200. The average of 1200 and 800, it will be 1000. This will be 1000. This gives me 6 by 10. So the value will be 0.6. Let's go to D. Will be 1200 minus 300. That will give me 900 upon the average of 500 and 1000, which is 750. So this will be 90 by 75. 15 5s are 75 and 15 6s are 90. This will be 1.2. Let's go to E now. E will be 1400 minus 1100. That will be 300 upon average of 1300 and 1100, which will be 1200. So this is 1 by 4. Value will be 0.25. Let's find for SPV for F. 2000 minus 1200 gives me 800 upon average of 1600 and 1800 gives me 1700. This is 8 by 17. You should know 1 by 17 is 5.88 percentage. So this will be 8 into 5.88 upon 100. Even if you take this as 6, so the value will be less than 0.48. Value will be less than 0.48. Let's write G here only. So G will be 1900 minus 1000. It will be 900 upon average of 1200 and 1700. That will be 1450. Okay, I have 500 extra. Yeah, so this will be 1450. This will again be 90 by 145. 5 ones are 5 8s are 5 2s are 10, 5 9s are 45. So this is 18 by 29. And if I divide this further by 9, 9 3s are 27.22 something. So 2 by 3, I know it is 0.66, and this will be somewhere less than 0.66. Okay. So we have the SPV values for all the from A to G. Now I think we should go back to our questions. So the question number 1 said that uh, which among the shares of A, C, D, and F had the highest SPV? So for A, I have zero point 0.6. For C also I have zero point 0.6. For D, I have 1.2. So currently D is the highest. And for F, I have something less than 0.48. So obviously D is the highest. So the answer for the first question will be D. Question number 2. Again, I need to find SPF. How many shares had an SPF greater than zero point 0.5 on that day? Okay. So SPF greater than 0.5. So A is greater than 0.5, B is not greater than 0.5, C is greater than 0.5, D is greater than 0.5, not E, not F. Now G. If you can see, G will be, yes, it will be less than 0.66, but it has to be more than 0.5 because this is not 2 by 4. It is more than that. So G will also be considered. So in total, I have 1, 2, 3, and 4 values. 4 shares greater than 0 0.5. So question number 2 is also done. Question number 3 says daily loss for a share is defined as opening price minus closing price upon opening price. Which among the shares A, B, F, and G had the highest daily loss on that day? Okay, so we can work this out here. So A will be for A, it will be, sorry, so for A it will be opening price minus closing price upon opening price. So it will be 2400 minus 1200, which gives me 1200 upon opening price, that is 2200. This will be 12 by 22, which means it is 6 by 11, and 6 by 11 is nothing but 1 by 11 is 9.09 percentage. So 6 by 11 will give me, okay, I'm sorry, I've made a mistake here. That's what I was wondering. So daily loss is opening price minus closing price. I had done highest price minus lowest price. So let's redo this again. A will be 2200 minus 1800, which will give me 400. And upon opening price again, so this will be 2200. Okay, so this will be 4 by 22. That means this will be 2 by 11. 1 by 11, I know it is 9.09 percentage. So this will be 18.18 percentage. So the value can be, will be 0.1818. Okay. So let's move on to the next share, that is B. It will be opening price minus closing price, 2000 minus 1700, so it will be 300 upon opening price, that is 2000. So this will be 3 by 20. I know 1 by 20 is 5%. 3 by 20 will be 15%, which means this will be 0.15. Let's take F now. For F, opening price minus closing price, 1800 minus 1600 is 200 upon opening price, that is 1800. So this will be 200 upon 1800. This is nothing but 1 by 9. 1 by 9 is 11.11 percentage. So this will be 0.11 and something. And the last share is G. So for G, opening price minus closing price. Okay, now see for G, the price is anyways increasing. So there won't be any loss here. It's already gaining. So for G, it will anyways be a profit. Okay. So which among the shares A, B, F, and G had the highest daily loss? So the highest daily loss is of A. So my answer to this will be D option, that is A. Question number 3 is also done. Let's move on to question number 4. What would have been the percentage wealth gain for a trader who bought equal numbers of all bullish shares at opening price and sold them at their day's high? Okay, so which ones are the bullish shares? Bullish shares are C, D, and G. Bullish shares are C, D, and G. So what this trader does is he buys. So for let's suppose for C, he buys it at the opening price, which is 800, sells it at the highest price, that is 1400. Similarly, for the next bullish share, that is D, he buys it at 500 and sells it at the highest price, that is 1200. So this will be 500, he sells it at 1200. Okay, and the next bullish share is G. He buys it at opening price, that is 1200, and sells it at the highest price, that is 1900. So this is for G, sells it at 1900. Okay, so what I need to know is percentage wealth gain. So for C, the gain will be 600, plus for D, the gain will be 700. For G, the gain will be 700 upon the total will be 1200 plus 800, 2000 plus 500, this will be 2500. The sum of the numerator will be 700. 700 will give me 1400 plus 600 will give me 2000. This will be 2000 by 2500, which means it will be, these both zeros will go, 5 fours are 20 and 5 fives are 25. So it will be 4 by 5, which is 80%. So it will be option B, that is 80%. So I'm done with question number 4 as well, which means we have completed this set. Okay, so let's move on to the next set. Let's look at the last set. Two students, Amiya and Ramya, are the only candidates in an election for the position of class representative. Students will vote based on the intensity level of Amiya and Ramya's campaigns and the type of campaigns they run. Okay, each campaign is said to have a level of 1 if it is a staid campaign, and a level of 2 if it is a vigorous campaign. Okay, campaigns can be of two types. They can either focus on issues or on attacking the other candidate. Okay, so I know that there are two candidates and they run campaigns based on intensity level, and also the types of campaigns are one in which they focus on issues and one in which they attack the other candidate. Okay, so let's move on to the next data set. If Amya and Ramya both run campaigns focusing on issues, okay, then the percentage of students voting in the election will be 20 times the sum of the levels of campaigning of the two students. For example, if Amya and Ramya both run vigorous campaigns, then it will be 20 into, so vigorous campaign is level 2, so that's why it is 2 plus 2, and that will make it as 80% of the total students that will vote in the election. Okay. Among voting students, the percentage of votes for each candidate will be proportional to the levels of their campaigns. For example, if Amya runs a staid, that is level 1 campaign, while Ramya runs a vigorous, that is level 2 campaign, then Amya will receive 1/3 of the votes cast and Ramya will receive 2/3. So this means that if Ramya is running a vigorous campaign, so the person running a vigorous campaign will earn 2/3 of the votes, and the one running a staid campaign will earn 1/3 of the votes. So yeah, I understand if the data is a bit intimidating to you right now. So what we can do is we'll try to consolidate this piece of data into a table. So what we can do is we can take two parameters here as of now, because we know in this data up till now we have talked about intensity level, right? If the intensity level is 1 and it's 2, so how the voter turnout will change. Okay, so what we'll do is we'll try to capture that data. So first, let's try to capture data related to intensity levels. Okay, so I have Amia here and I'll have Ramya here. Okay, so the types of intensity, that the intensity levels that they operate on is either staid or it is either vigorous. Ramya as well, it will be either staid or it will be vigorous. Okay, so let's make a table. Okay, so now for staid, we know staid is level 1, staid is level 1, vigorous is level 2, staid is level 1 and vigorous is level 2. Okay, so when both are staid, it will be, I know the formula that's given to us will be 20 into level of 1 plus the level of other, and that much percentage. So here it will be 20 into 1 plus 1, which is 40%, right? Here this will be 20 into 2 plus 1, this will be 60%. This is the voter turnout that we are calculating. This will be 20 into 1 plus 2, that is 60%, and this is 20 into 2 plus 2, that is 80%. Okay, now we have calculated the voter turnout here. So for Amya and Ramya individually, how the data will look like. Okay, so I know that if the person who runs, the candidate who runs a vigorous campaign will receive two-third of the vote, and the one with stayed campaign will receive one-third of the vote. But when both of them run a same intensity level campaign, they'll earn equal votes. Okay, so I have Amya here, Ramya here, so yeah, both will get 20%. Okay, and because the percentages a percentage of the votes, they are proportional, right? So here as well, this is 40% and 40%. Okay, now in the cases where one is vigorous and one is stayed, so let's calculate that. So here I know Amia is stayed, so she will get one-third of the vote, so this will be 20%. Ramya will get two-third, this will be 40%. Similarly, here Amya now runs a vigorous campaign, so she will get two-third of the votes. So this will be 40% and this will be 20%. So now I think this data is pretty easy to read, and we can move ahead to the next data set. Okay, so the above mentioned percentages change as follows. If at least one of them runs a campaign attacking their opponent, okay, if Amya runs a campaign attacking, okay, so now I think we are moving on to the second part, that was there will be two types of campaign. One is a campaign where the candidates focus on issues, and the other campaign where the candidates attack the other candidate. Okay, so we are moving on to that piece of information here. So if Amya runs a campaign attacking Ramya, okay, so here Amya is attacking, and Ramya runs a campaign focusing on issues, and Ramya is focusing on issues. Then 10% of the students who would have voted for Amya will now vote for Ramya, and another 10% who would have otherwise voted for Amya will now not vote at all. Okay, so the person who is now taking the attack strategy for the campaign, that person will lose 10% of its voters to Ramya, and 10% of its voters will now not vote at all. So we are talking about Amya here. Now let's see for Ramya. If Ramya is attacking Amya now and Amya is focusing on issues, then 20% who would have voted for Ramya will now vote for Ramya, and 5% who would have voted for Ramya will now not vote at all. Okay. So finally, if both are attacking each other, then 10% of the students who would have otherwise voted for them, had they run campaigns focusing on issues, will now not vote at all. So this means that if both of them are attacking each other, 10% of the students, their respective voter turnouts, they will now not vote at all. So again, I understand if this piece of information is also a bit intimidating to you. There's a lot of information given here. So again, let's try to identify what are the parameters that we are discussing here. So the parameters are focusing on issues and attacking the types of campaigns, right? One is focusing on issues, the other is attacking. So we can prepare a table with respect to these two parameters. So let's have a strategy type table. Okay, so I have Amya's data here. I'll have Ramya's data here. For Amya, the first the first parameter will be issues, the second will be attack, and here as well, one will be issues, other will be attack. Okay, so okay, now let's compare table quickly. Okay, so let's write all the data that's given to us. If AMEA runs a campaign attacking, AMEA is okay. So one thing, if AMEA is also running a campaign focusing on issues and RAME is also running a campaign focusing on issues, there won't be any problem, right? And we don't have any data with respect to that. So here, there won't be any data. Now, if AMEA is attacking and RAME is focusing on issues, 10% of AMEA's voter will now vote for RAMEA. Correct? That's given to us. And another 10% who would have voted for AMEA will now not vote at all. So another 10% will now not vote at all. Okay, so we are done with this. Let's go on to the second point. If Ramya runs attacking campaign, okay, so now if Ramya is attacking this one and Ramya is focusing on issues, so I have to fill this particular box. Then 20% of the students who would have voted for Ramya will now vote for Ramya. So 20% of Ramya's votes will get redirected to Amya, and 5% will now not vote at all. 5% of Ramya's people will now not vote at all. Okay, so I'm done with second point as well. If both campaigns are attacking each other, okay, if both are attacking each other, so this is the last data that I have to fill. Then 10% of the students who would have voted otherwise voted for them, had their own campaigns on focusing on issues, will now not vote at all. Okay, so 10% of Amya as well as 10% of Ramya, they will now not vote at all. Okay, I think this is pretty much it. We were not trying to find anything here. We just simplified this data into the tables. That's all we can do. Now let's move on to the questions and try to solve them. So the first question says, if both of them run staged campaigns attacking the other, then what percentage of students will vote in the election? Okay, so both of them are running staged campaigns. So this is the data that I have for that. I'll have 20% voters for who will show up for A and 20% for R. So let's write that here. A will have 20%, R will have 20%, and they both are attacking each other. Then what will be the percentage of students who will vote? So if both are attacking each other, so that means we have to look here. Okay. So if both are attacking each other, then 10% of A will not vote, 10% of R will not vote. So 10% will not vote from here, 10% will not vote from here. I'll be left with 18% here and 18% here. The overall percentage of students that will vote will be 18 plus 18, that is 36 percentage. So my answer to the first question will be D, 36%. Let's move on to question number 2. What is the minimum percentage of students who will vote in the election? Now, I want to find minimum percentage of students who will vote in the election. So for this, what I can do is I'll take the voters where I'll take the data where the voters are already low. So I can straight away think of this. Okay, when both are running staged intensity campaigns, they both have 40% of the voters. So for 40% of the voters, I'll have to minimize this further, okay, to find the minimum percentage of the students who will vote. So how do I minimize overall voters? So if you look at the in a strategy type table here, so if let's look at if Amya is focusing on issues and Ramya is attacking this piece of data. So overall, how much? So overall, 20% of R is getting redirected to A. So we are not really losing out voters here. So only 5% of R will not vote. This means that in this entire situation, I'll lose only 5% of the voters. Similarly, let's look at the other two conditions. Here, I'm losing overall 10% of the voters because the other 10% is anyways just getting redirected to R. I'm not losing it. And in the final condition where both of them are attacking, I'm losing 10 plus 10, 20% of the voters. Okay. So that will really give me the minimum percentage of the students. So I'll take a condition where Rama and Amya both are attacking, and I'll 10% of voters will now not vote, 10% of R will not vote, which means that overall 10% will now not vote. So this will be 36 percentage. So the answer to my second question will be option B. Let's move on to the third question. If Amya runs a campaign focusing on issues, okay, Amya is now running a campaign where she focuses on issues. So I just have one condition to be looked at here. Then what is the maximum percentage of votes she can get? Okay. So what do we have here? If Ramya is attacking and Amya is focusing on issues, I know that 20% of Ramya's vote will get redirected to Amya and 5% of Ramya will not vote. So, okay, I don't have to do anything with that. I'll just, my important point that I have to focus on here is that 20% of Ramya will get redirected to A. So I'll look for a case where I already have a high voter turnout for Amya, and along with that, I'll have a high voter turnout for Ramya, so that when the 20% of Ramya gets added to Amya, I'll have the maximum percentage of voters, right? So if I have to look at such a case, if I have to find such a case, so I can my attention directly goes to this case where Amya is 40% and Ramya is 40%. Amya is already at the highest point. Okay, there's no condition in which Amya gets more than 40% of the vote. And since I have to redirect some of the votes from Ramya as well, that is 20% of the votes, I'll take 40% so that I get maximum. So the two data points that I'm looking at, Amya will be 40%, will have 40% votes. Ramya will have 40% of the votes. They both are running campaign. Amya is running campaign focusing on issues. Ramya is attacking, which means 20% of Ramya's voters will get added to Amya. Okay, so 20% of uh, Ramya's voters. Okay, this looks wrong. Okay, 20% for this will be 8%. This will give me 48%. That's my answer, option A. We are done with question number 3. Question number 4 says, if Ramya runs a campaign attacking Amya. Okay, so what I'm looking at here, Ramya is now attacking Amya. Okay, then what is the minimum percentage of votes she is guaranteed to get? Okay, so the minimum percentage of votes that Ramya will definitely get. So let's look at the cases where Ramya is getting lower votes. So I'll have a case where Ramya is stayed. So in both of these cases, Ramya has 20%. So which means that Ramya, I have to take 20% because I have to, find minimum percentage of the votes. So Ramya's votes, I'll take it as 20%. Now, how can I minimize this further? Okay, so as to find a case where she'll get the minimum votes, like she can't go lower than that. So with that, I can get minimum percentage of votes that she'll be that is guaranteed she'll get. Okay, so when R is 20%, um, here if you look at this case, okay, I know that Ramya is attacking. If you look at this case, 20% of Ramya's votes are redirected to Amya. Okay, so and 25%. Okay, so overall here, if you see, 25% of Ramya's votes are getting redirected somewhere or they are getting lost. By getting lost, I mean that those 5% of the voters are not voting at all. And here, overall, Ramya is losing only 10% of the voters. And I have to minimize Ramya's votes. So what I'll do is I'll take this case where she is where her 25% of the voters are getting reduced. Okay, so I have already taken the lowest possible voters for Ramya, which is 20%, and from this case I'll have 20 plus 5, that is 25% removed from 20%. All I'm left with is 15%. Okay, I hope you're getting this. So Ramya is so 15% will be the percentage of votes that she will get in the worst condition. Okay, she is guaranteed to get 15% of the votes. So this is my option A. I'm done with question number 4 as well. Now let's move on to the last question. What is the maximum possible voting margin with which one of the candidates win? Okay, so I need to find maximum possible voting margin. So see, when we talk about voting margin, the spectrum of uh, the spectrum of the difference that I'll have will be maximum when both of them will have different votes, right? For example, if we take cases where both of them are having same votes, even if we reduce them with our best conditions, even if we take this case where 20% is getting redirected to A, and if even we take these cases where 10% is getting redirected, 10% of them are not voting, still the spectrum that we'll get will be not wide as it can get when both of these values are different. Okay, so it should be pretty clear if you can understand it. Okay, I'm just trying to explain it anyways. So we'll take cases where either A is 40, A is 20 and R is 40, and even we'll check for A is 40 and R is 20. Okay, so let's take a case first where we know that A has 40 percentage of votes and R has 20 percentage of votes. Okay, now when we talk about having a broader spectrum of voting margins, so we'll look at cases where they are getting reduced significantly. Okay, so this is the case that we can simply ignore because 10% because losing 10% in A and similarly 10% in R won't create any such like huge voting margin. Okay, and we can already visually make out that these two of them will create a good enough uh, voting margin that we can look at and check. Okay, so let's take first case where Ramya is attacking and Amya is focusing on issues. So 20% of Ramya is getting redirected to A. Okay, so I already have 40% here. 20% will get redirected here. This will be plus 4%, which will be 44% in total. And 5% of R will now not vote. Okay, so 5% will not vote. So this means that one will not vote and four we have already removed. So total five will get removed. I'll be left with 15% of votes for Ramya. So the range, the voting margin that I am looking at here is 44 minus 15, which is 29%. Okay, so let's take second condition where Amya is attacking and Ramya is focusing on issues. So 10% of Amya will get redirected to A, 10% of Amya will get redirected to R. I'm sorry. So 4% I already have it at 20%. 10% of A will come here. This will be plus 4%, and 10% of A will now not vote at all. So it will, so all in all, this will be 32% that will be left. And this will give me 24%. So the margin that I'm looking at here is 32 minus 24, that is 8%. So, it's obviously we can ignore that. Let's look at other cases. The second case only actually where A is 20% and R is 40%. Okay, so in this case, if we take Amya focusing on issues, Ramya focusing on attack, 20% of R goes to A. So A is at 20% and 20% of R goes to A means I'll get 8% here. This will be 28%. And Ramya 5%. So overall Ramya will lose 20 plus 5, 25%. So this will be 30% left. The margin that I'm looking at here is 2%, right? Again, we can simply ignore it. We already have got the highest one, which is 29%. So the last case that I have to look at is when Amya is attacking and Ramya is also attacking. Sorry, when Amya is attacking and Ramya is focusing on issues, 10% of A is getting redirected to A. So I already have 40% here. 10% of A is coming here, and okay, so that's it. This is 42%, and A is losing out 10% to R, and 10% to of them are not voting. So A is losing 20% in total, which will give me 16% as left. Okay, so the margin that I'm looking at here now is 42 minus 16, which will be 26%. Okay, so what is the maximum possible voting margin? It is 29%. So my answer will be D, 29%. So we are done with this set. I understand the data was pretty overwhelming to read at first, but if you take this approach, you consolidate into a simpler table format, so it gets easier to solve the questions as well. Okay, so yeah, we are done with set number 5 as well. That will be all from my side, guys. If you like this session, Please share it with your friends. And we'll continue with this series. We'll solve all the past year papers one by one. And as always, I'll be waiting for your doubts in the comments. See you soon and bye.